Okay, today we will be discussing trigonometric functions and some properties of basic trigonometric functions. I'm not going to give you the definitions, but there will be some very basic things. For example, the values of trigonometric functions using the table. So if you use the table, how do we compute the exact value of this expression? Let me draw the table here. Special angles in trigonometric functions between 0 and 90 are 0 degrees, 30, 45, 60, and 90 degrees. Right? So these are the main values of trigonometric functions that you should know. And let's find the sign of this. Sine alpha. Let's say sine 0. Sine 0 is going to be 0 over... So let me write it in this very interesting way. 0 over 2. And then for this one, root of 1 over 2. So this is going to be root of 2 over 2. This is root of 3 over 2 and root of 4 over 2. So we have dividing 2 in all fractions and numerators are from 0, 1, 2, 3, 4. If you just simplify these expressions, that's actually 0, that's 1. So the rest, stays same because root of 2 is irrational. Root of 3 is also a irrational number. And for this one, root of 4 is 2. That's why this is 1. So this was 1 over 2. Now, how about the cosine? Cosine alpha is very similar, but you have to do in reverse order. So you start with root of 4 over 2, root of 3 over 2, root of 2 over 2, and 0 over 2. So we have 0, 1 over 2, and 1 here. So overall, these are the very main numbers, main values of sine and cosine function. Everything else can be derived from these values. So for example, if we start solving our problem, equals 2 times sine 30 degrees. It's 1 over 2, 1 over 2 minus root of 3, sine of 60. Sine of 60 is root of 3 over 2. And what about cotangent 45? Cotangent is, recall that cotangent 45 is equal to, so that was cosine 45 over sine 45. So if you divide cosine 45 by sine 45, here we have the value of cosine 45 and sine 45. Both equal to each other, so that would be cotangent 45 is 1, and tangent is tangent 30 degrees. It's sine 30 over cosine 30 degrees. Sine 30 degrees is 1 over 2 over cosine 30 degrees, root of 3 over 2. So these are all the values. Now you have to do is algebra, simplify the expression. So here, these two cancel. We have 1. Here you can cancel out these 2's because denominator of numerator and denominator of denominator, they are both are equal to 2. So basically we have here 1 over root of 3. And this root of 3 can be cancelled out with this one. So in the end, we are left with root of 3 over 2 only. So this is a rational number and this is just 1 integer number. So you can't subtract it. So that's the final answer. The result of this expression is 1 minus root of 3 over 2. Next, we have the following problem. Find the range of 2 minus 3 sine alpha. As you may have seen from the table, the values of sine will range from -1 to +1. So the values of sine and cosine, so the same goes for cosine, is maximum 1 and minimum -1. So if you are asked to solve some equation like this, it means there is no solution. Sine cannot be greater than 1 or less than -1. So it's between -1 and 1. So which means if I just multiply this by 3, so if I just multiply all the sides, so this becomes -3, sine alpha is less than 3. So 3 sine alpha will be between -3 and +3. So if I flip the signs, that's going to be just flip everything. If I multiply this by -1, it's going to be 3. So flip the signs, -3 sine alpha. So negative 3 sine alpha is still between negative 3 and positive 3. If I add 2 to every side, so if I add 2 here, plus 2, and plus 2, I'll have 5 greater or equal to minus 3 sine alpha, and this is negative 1. So that means 2 minus 3 sine alpha, the value of when you plug any alpha inside this 2 minus 3 sine alpha expression, you get something between negative 1 and 6, negative 1 and 5. So that's the range. So the range of this expression is starting negative 5 to negative 1 to 5. So that's the range of values of this expression. When you are trying to solve this type of problems, whether it's sine or cosine or something different, you start with something that you already know and try to push that thing that you know to the question. So what we did here, we know that sine is between negative 1 and 1. We try to push that to a function which is 2 minus 3 sine alpha. So multiply that by number, add some number, or other types of operations. This question is kind of continuation of the previous problem. We can use the same type of arguments from the previous problem and analyze whether this sine alpha plus 2 cosine alpha can be equal to 3 or not. Since we know that sine alpha is at most 1 and cosine alpha is also 1 at most. So if I multiply this by 2, I get 2 cosine alpha is at most 2. So combining these two inequalities, sine alpha plus 2 cosine alpha is at most 3. The question wants you to make it equal to 3. So the values where the sine alpha plus 2 cosine alpha is equal to 3. So when, for which alpha this equality holds. To make this equality hold, sine alpha, this one has to be 1 and this one has to be equal to 2. Otherwise, if sine alpha is less than 1, imagine sine alpha is less than 1. That means the rest of the 2 cosine alpha will have to compensate the rest of to fill to 3. So that this has to be greater than 2, which is impossible. From here, we can see that sine alpha is 1, and from this one, if you divide both sides by 2, cosine alpha is 1. So, but the problem is sine alpha and cosine alpha, they can't be equal to 1 at the same time. So if one of them is 1, the other one has to be 0. Because of, remember this identity between sine and cosine is 1. So sine square plus cosine square is 1. So if both of them are 1, 1 square plus 1 square would have been 2. So they can't be equal to 1, both of them at the same time. That's the problem. So, which means this equation doesn't have any solutions. So there are no alpha which could make this equality hold. So here's another problem where you should not go deep, very deep into cosine and sine and try to evaluate these expressions, because cosine pi over 11. So if you say that pi is 180 degrees, so in terms of degrees, it's 180 over 11. So it's a number between, so if you divide 180 by 10, it's 18. So this is around, let's say, 16 or 17. Value of this expression is less than 1 and greater than 0. So it's between 0 and 1, cosine pi over 11. And what happens if you take a square of a number which is between 0 and 1? So what happens if I take the square? Cosine square pi over 11 between 0 and 1. The number becomes smaller because look at this expression. 1 over 2. It's a number between 0 and 1. If I take its square, it's 1 over 2 square, right? Which becomes 1 over 4. And 1 over 4 is less than 1 over 2. So if you take a square of a number between 0 and 1, the number becomes less. So which means cosine pi over 11 is greater than square of cosine pi over 11. But the trick here is what happens if the cosine pi over 11 was negative. The value of cosine function is negative, and when you take the square of that negative number, it becomes positive. Regardless of the value of cosine, which is negative, the absolute value will be greater, but the number itself, since it's positive and the other one is negative, the positive one is always greater. So you have to make sure that this cosine is always positive. So if this, for some reason, for the reason of the angle, becomes negative, and this is a square, it's always positive, then this side is greater. And for the final problem, we are going to use the most famous identity of trigonometric functions, or Pythagorean theorem in trigonometric functions. Sine square plus cosine square is 1. So what happens? Say sine square, we don't know what sine square, plus cosine. So that's negative 7 over 25 square is 1. And sine square alpha will be 1 minus 7 square over 25 square. Or if I do the computations here, it's like 25 square, 25 square minus 7 square. That would be 25 square. I don't need to take the square. Also, I know that 1. So there are several very common Pythagorean triples, like 3, 4, 5, or 6, 8, 10, what else? 5, 12, 13, right? And then 7, 24, 25. So these are very common ones. So you probably should know this at this point of your mathematical journey. I don't need to take the square and multiply, write the square of 24 here and 25 here. I just want to do square root of this and this one. So sine alpha is plus minus 24 over 25. So, but the thing is, sine alpha is a single number, so you can't assign two different plus or minus. So you have to choose whether it's plus or minus. Where it comes this sign chart of the function. So when I say sign chart, it's sine plus or minus. So for a sine function, for sine alpha, in the first and second quadrant, if the alpha is in the first and second quadrant, the value of sine is positive. In the third and fourth quadrants, it's negative. And this one says that alpha is in the third quadrant. It's here. So that means the value of this sine has to be negative. So instead of, so here I choose, so here I choose negative 24 over 25. So sine alpha is negative 24 over 25. So this was basic ideas about trigonometric functions. So in the next upcoming videos, we are going to see more complicated equations, inequalities, and reduction formulas.